In this video, I will continue to solve the homework problems in the Circle Geometry Lesson Number 2 homework package, and I'll be starting on question number 4. So for question number 4, I'm given a circle with center O, so this is my center right there, and the side AB is parallel to the side OC. So let's take a look at the side AB. Here's AB. And the side OC, those two lines there, they may not look like it, but they are parallel. So that will open up to a few more properties. And angle A is 55 degrees. So you would put 55 degrees right here in that corner. Okay, so let's go ahead and find angles 1 and angle 2. All right, so one thing that I'll do for this particular problem is over here where I'm highlighting in green, that's a radius, so I'll mark in a line there. And this is also a radius, so I'll mark in a line there. And from that, I've created a isosceles triangle. So this blue region right here, that's an isosceles triangle there because the two sides are equal. So if the two sides are equal, then I know this corner angle is also going to be 55 degrees. Now that's useful because if I take a look at the two parallel lines here, so let me just kind of erase the screen part now. If I go back and if I focus my attention on the parallel lines here in red, you see that there's a Z shape here that's forming. So one of the rules that you often learn in the elementary geometry course is that if two sides are opposite, if they're parallel like I have over here, then these two inside angles are equal. That's called the alternate interior angles property. So that applies over here because if this is 55, that means angle 1 also has to be 55 degrees. So angle 1 is going to be 55 degrees by using the alternate interior angles property. Okay, let's go ahead and continue solving the problem here. Remember, this is a isosceles triangle here, and since we know the corner angles are 55 and 55, that means we can find this inside angle right there because we know angles in a triangle add up to 180 degrees. So 180 minus 55 minus 55, that's going to give you 70 degrees right here. So that's 70 degrees. Okay, so if I just kind of clean up this problem a little bit now to solve angle 2, we know this is 70 and we know this is 55, and over here, this blue angle, that's angles on a line. So that whole angle adds up to 180 degrees. So in order to find angle number 2, I would take 180 degrees minus 70 and minus 55. And if I do that, that will give me the value of angle 2, which is going to be 55 degrees. Okay, so angle number 2 is also going to be 55 degrees. Okay, let's move on to question number 5 now. Okay, so for question number 5, I have a square, ABCD. So here's my square, ABCD. Now, when you're dealing with a square, you know that all sides are going to be equal because that's the property of a square. So inscribed means it's inside the circle and its radius is going to be 12, and I need to find the perimeter of the square. Okay, so one of the key numbers that we're given is the radius, which is 12. So that means from the center to the edge of the circle, this is going to be 12. And I also know that from the center to this opposite edge here, this is also going to be 12 in blue. So if you put that together here, I'll try to put this all in blue now. Here's a triangle right here. And if I redraw the triangle over here, it kind of looks like this. This total length here in yellow, that's going to be 24. So there's a 90-degree box right here, so my hypotenuse is 24. And I also know that all the sides are equal, so I can label this side as x, and I can label this side as x. So the two legs have an unknown value, and I can label that as x. So now we can use the Pythagorean theorem here because I know my legs are x and x. So to set that up, that's going to be x squared plus x squared equals to the hypotenuse, which is 24 squared. So now I have a hypotenuse, now that I have a Pythagorean theorem equation set up, I can go towards solving this now. So x squared plus x squared is going to be 2x squared equals 2, and 24 squared is going to be 576. After that, I can divide both sides of the equation by 2. If I do that, these 2's will cancel off. And now I get x squared equals to 576 divided by 2, which is going to be 288. And then I can take the square root of both sides. And if I take the square root of both sides, I get x equals to 16.97. And you can work that out with a calculator. Now that's useful now because if I go back to my original diagram here, if I go ahead and erase all the colors here, I know that this length right here is going to be 16.97. Okay, so in order to find the perimeter, I know every single other length is going to be 16.97. So basically I can do 16.97 and times it by 4. If I times that by 4, I will get 67.88 as my final answer for that particular problem. Okay, let's move on to the next question. Let's move on to question number 6 now. Okay, so for question number 6, I'm given another triangle inside a circle. So I know that side AB, I know that side AB, which is this side right here, is going to be equal to side AC, which is right there. So what that tells you right there is that this is an isosceles triangle right there. And I know that angle A is going to be 40 degrees. So that's going to be 40 degrees up there. And we know that the two corner angles have to be equal. So if I do 180 minus 40, that gives me 140 degrees. And if I divide that by 2, I'm going to get 70 degrees. So I know that these two corner angles are 70 degrees. Okay, let's go ahead and see if we can solve the rest of this problem now. I need to find angle AOB. So in order to find that angle AOB, it's actually not on the diagram. We have to create it, and the way we create that is by I can draw in a radius right here. So this blue line is a radius. And I also know that this right here is also a radius right there. And the goal is to find, I need to find this green angle right here. This green angle right here, that is angle AOB. Okay, so that question's not too bad. This problem's not too bad because if I take a look at the right-handed corner here, which is angle C, this is an inscribed angle. And if I go ahead and follow the sides, which I'm highlighting in red, it opens to this arc right here, this red arc. And I know that angle AOB, this right here in the middle, is a central angle. So a central angle. And if I go ahead and follow its sides, which are already highlighted in blue, and it opens to this arc right here, right? So if the inscribed angle and the central angle open to the same arc, that means the central angle is going to be double the inscribed angle. So that means angle AOB has to be 140 degrees. Okay, so angle AOB is going to be 140 degrees because it's going to be double that angle because it opens up to the same arc. All right, let's move on. Question number 7 we're going to skip, and let's move on to question number 8 now. For question number 8, I need to find the different angles here. So angle 1, this is an inscribed angle. And if I go ahead and follow its sides, which I have in several problems now, it opens to this green arc on the opposite end. And you'll notice that at angle O, this is the central angle. And if I open up the central angle to its sides, it also opens up to the same arc. So my central angle is going to be 150 degrees. And that means the inscribed angle has to be half of that. So if I take 150 degrees and divide that by 2, I get 75 degrees. So angle 1 has to be 75 degrees. Okay, so that's because the inscribed angle is always half the value of the central angle if the two angles open up to the same arc. Okay, let's erase all that. After that, I will go ahead and label the radius. So here's a radius. And there's a radius, and over here there's a radius. So once you've done that, you created some isosceles triangles, and we can definitely find these corner angles right away because this entire triangle right here adds up to 180, and those two corner angles are equal. So in order to finish that off, just take 180 degrees, and then we can subtract 50 degrees from that, which gives us 130, and then take 130, divide that by 2, and 130 divided by 2 is going to be 65. So this is going to be 65, and that's going to be 65. right? So angle number 2 is going to be 65 by the isosceles triangle property. And then for angle 3, once again, we can use the isosceles triangle property. If I've used up 100 degrees in this triangle right here, in this red triangle right there, if I've used up 100 degrees, that means 80 degrees is left, and 80 divided by 2 is going to be 40 and 40. So angle 3 is going to be 40 degrees. And if I add up all three of these angles, that gives me 180 degrees for that last particular problem. Okay, so that question is not too bad. Let's move on to question number 9. I need to find angle number 1. So for questions number 9 and the next one, number 10, they're going to be very similar, and you do need to set up some an algebraic approach for those particular problems. So let's take a look at this problem here. The very first thing I would do is I would label this angle over here. This is an inscribed angle, and I'm going to label that x. Now, if I take a look at that inscribed angle, and if I follow its sides, it opens to this arc below in green. And if I label the middle angle, this is my central angle, and if I follow its sides, it also opens to this exact same arc. So we know that the central angle is always going to be double the inscribed angle. So if my inscribed angle here, now that I'm highlighting in blue, that's x, doubling that will give you a value of 2x for the central angle. Okay, so that's going to play a part in this question a little bit later on. Okay, in order to kind of set this problem now is, let's take a look at this individual triangle right here, this yellow triangle right there. Okay, so if I need to just kind of relabel things, angle 1 right here, this is going to be 2x, and then there's also this green angle right here. I'll label this green angle B, and this angle down here is going to be 22 degrees. So all I know is if I take my 2x and this angle B and this 22 degrees, if I take all three of those angles and if I add them all up together, we know that has to equal to 180 degrees, because in a triangle, all angles add up to 180 degrees. Okay, let's erase this now. Oops. Okay, so if this angle right here is B, that means the opposite angle over here, this also has to be B, right? That's one of the angle properties. Vertically opposite angles are equal. So if I take a look at this blue triangle now, let's take a look at all three of the angles. I have X, I have 50 degrees, and I also have this angle, which is B. Now if I add up all those angles, I would get X plus 50 plus B. That also has to equal to 180 degrees for that particular triangle. Now what you're going to do now is you're going to take a look at these two equations here in yellow, and you're going to relate them together. So you see this 180 degrees right there? Well, we know 180 degrees is the same thing as that 180 degrees. So instead of writing 180 degrees here, I can erase this thing now and substitute it with this expression, which is going to be x plus 50 plus b, because both those expressions equal to 180 degrees. So we can make both those equations equal to each other. Now if I do a little bit of math here, I know that this b and that b will cancel off. If I bring this x to the other side, combine it with that, it's going to be 2x minus x. And then if I take this 22 and bring that to the other side, it's going to be 50 minus 22. So 2x minus x is going to be a single x, and 50 minus 22, that is going to be 22. Sorry, 50 minus 22 is going to be 28. So the value of x is 28. Okay, so let's go back to my original diagram here. Let me just erase all this. A lot of work here. Remember, this is my original x, right, in this corner angle here. So this x value has a numerical value of 28 degrees, and we know angle 1 is the central angle, and the central angle is always going to be double the inscribed angle. So angle 1 has to be double 28, which is 56 degrees. So that's how you solve that particular problem. That question has a little bit more algebra than all the other questions. And a good follow-up question is now question number 10, because it's pretty much the exact same kind of problem, just different numbers. Okay, so let's go ahead and label this corner angle right here, this is the inscribed angle, and I'll label that X. And if I go ahead and follow the sides right here, that inscribed angle opens up to that arc. And if I take a look at the middle angle here, the central angle, and if I follow its sides, it also opens up to the same arc. So what that means is the central angle is always going to be double the inscribed angle. So remember, the inscribed angle up in this corner is X, so my central angle has to be 2X. Okay, and let me just erase all the colors now. Okay, so I've labeled my triangle X and 2X there, and I know that this angle right here, I don't know what that angle is, so let's just call that angle B. If that's angle B, then the opposite angle here, that has to be B as well. Okay, and now we can use the same kind of idea as the previous problem. If I take this blue triangle right here, if I take a look at all three of the angles, which are X, B, and 36, so X plus B plus 36, that's going to equal to 180 degrees. And then if I take a look at this yellow triangle right here, if I take a look at all of the angles, I've got a B here, plus this 2X, plus this 20 degrees. That also equals to 180 degrees. Okay, and now we take a look at these two equations, and we can make them equal to each other because they're both equal to 180 degrees. So instead of writing 180 degrees here, I can replace that with the B plus 2X plus 20, which is that expression right there. And now we just have an algebra problem. Now we have an equations problem here, so the b's can cancel off. I can take this x and move it to the other side and combine that with the 2x there. So this is going to be 2x minus x. And then I can also take this 20 and move that over here and combine that with the 36. So that'll be 36 minus 20. All right, so 36 minus 20 is going to be 16. And 2x minus x is going to be a single x. So the value of x is going to be 16 degrees. Okay, so let's go back to my diagram here. And let's go ahead and erase all the colors now. Okay, so remember, this was labeled x, right? And x has a value of 16, so this is going to be 16 degrees. Whoops, I wrote 60, so this is going to be 16. And the central angle down here is going to be double that, so that's going to be 32 degrees. So angle number 1 is 32 degrees. Okay, let's move on to question number 11 here. For question number 11, I have side OA, which is this side right here, and it's parallel to side BC, which is down right there. So let me just use red colors here. If these two lines are parallel, we can actually create a Z shape right here. And we can use the alternate interiors property where I know that this angle and that angle are equal. But it also works for this green Z shape over here that I'm drawing. And what that means is that this angle in green is going to be equal to that corner angle there in green. So those are some properties that we can discover right away, given that OA and BC are parallel. So remember, this is the symbol that represents that the two sides are parallel. And angle AOC is 40 degrees. So what that means is this angle here, that's going to be 40 degrees. Okay, so that's 40 degrees, then this right here also has to be 40 degrees. Okay, other than that, let's see what else we can do to solve this particular problem. Let me just erase some of the color lines here. And let me just put in the 40 there and the 40 there. And now let's go into the central angle and the inscribed angles property. So we know this angle is a central angle. And if I open up its sides, it opens to this arc. And if I take a look at this inscribed angle at angle B, this is an inscribed angle. And if I go ahead and open its sides, it also opens to the exact same arc. So that means the inscribed angle is half the value of the central angle. So this has to be 20 degrees. If that's 20 degrees, then we know that this 20 and that 40, that's 60 degrees. So 180 minus 60 is going to be 120 degrees. So this has to be 120 degrees for that particular angle right there. And in order to finish this problem off, let me just kind of erase this again, all of this. We just found out that this angle here is 120 degrees. and this entire angle here has to add up to 180 degrees because that's angles on a line. So 180 minus 120 is going to give you a value of 60 degrees. So angle number 1 has a value of 60 degrees. Okay, let's keep on moving forward. We just have a few more problems to go here. Question number 12. All right, so this kind of question, we have to understand a few more properties because we're given that ABCD is a parallelogram. So this red shape right here, that's a parallelogram. Now, when you're dealing with the parallelogram, let me just redraw the parallelogram down here. There are a few properties that you do need to know, and that is that these corner angles are equal. Those corner angles are equal. And the bottom angles, this green angle and this blue angle, these two angles add to 180 degrees. So those are some properties of a parallelogram that are useful to know in order to solve the next problem. All right, so for the next problem, we know that angle B is going to be 55 degrees. So let's go ahead and plug in 55 degrees right there. And if we know that's 55, we know that the opposite angle here is also going to be 55 degrees. Okay, so that's really good. And then we know that this angle here and this blue angle there, those two angles have to add up to 180 degrees. So I can do 180 minus 55 degrees. I can do that really quickly, and that's going to be 125. So this is going to be 125 degrees. Let me erase that now. Is that 125 degrees? Okay, and let's go ahead and see if we can find angle number 1 now. And our next step is, let's take a look at angle E now. Angle E is at the very bottom here. This is inscribed angle. And if I go ahead and follow its sides, it opens to this blue arc over here. Now that's going to be useful because if I just erase my original parallelogram, take a look at this inscribed angle over here. If I follow its sides right here all the way to the ends, it also opens to the exact same arc. So if two inscribed angles open to the same arc, that means the angle values have to be the same. If they're opening to the same arc, then the angles should be the same, right? Okay, so that's 55 degrees. And that's going to be useful now because, let me just erase all this. Take a look at this blue triangle now. Try to make it as big as possible. So on the outside, so maybe I'll do that in yellow here. So this yellow triangle right there, that's a triangle as well. And this is 55 degrees, that's 55 degrees. So we should be able to find that angle as well. So 180 minus 55 minus 55, that's going to give me a value of 70 degrees. All right, that's going to be useful because in my final steps here, let me just erase all this. Let's take a look at this four-sided shape right here in blue. Anytime you have a four-sided shape, the interior angles always add up to 360 degrees. So since we have 3 out of the 4 sides, I can find angle number 1 now by doing 360 degrees minus the 70 degrees minus the 125 degrees minus the 55 degrees. And if I do that correctly, I should get 110, I believe. Just double check that. Yep, I get 110 degrees, so angle number 1 is 110 degrees. So once again, anytime you have a four-sided shape, the angles add up to, the inside angles add up to 360 degrees. And you don't need to really memorize that because I think the most common shape is a square or a rectangle, and we know that the corner angles are all 90 degrees. So 90 degrees times 4 is going to be 360 degrees. Okay, let's move on to the next question, question number 13. Question number 13 looks like another algebra question here. So just give me a second to blow this up, and then let's start analyzing it. Okay, so for this next particular problem, I'm going to start off in the corner here at angle X here. So this is an inscribed angle, and if I follow its sides, then it opens to this green arc over here. And if I take a look at the middle angle, the central angle, and if I open the sides there, it also opens to that same arc. So that means the central angle is always going to be double the inscribed angle. All right, so if my inscribed angle is 2x, and if I double that, that means my central angle is going to be 2x. Okay, that's step number one. Let me erase this now. Okay, so I know that middle angle is going to be 2x, and now we know that this green side, that's a radius, and I know that this green side, that's a radius. So now I have an isosceles triangle right here in blue. And what that means is we know that the corner angles here in red, the corner angles are the same. So the corner angles have a value of x plus 10. So I know that x plus 10, which is one of the angles, plus the other angle, which is also going to be x plus 10, plus the third angle, which is now going to be 2x, I know that has to equal to 180 degrees because that blue triangle, the interior angles add up to 180 degrees. All right, from here on, this is now solving a linear equations here. So x plus 2x, that's going to be 4x. So I can get rid of those guys. And then I know that 10 plus 10, that's going to be plus 20. And that's going to go to 180 degrees on the other side. And now we can solve this equation here. This is going to be 4x. And if I take my 20 and move it to the other side, 180 minus 20 is going to be 160. And then I can divide both sides by 4. And x is going to equal to 40. Okay, so x equals to 40. And what do we need to find? Yeah, just x, right? Okay, yeah, so then that means the final answer there is going to be 40 for that particular x value there, 40 degrees. Okay, let's see if we can move on to a few more other questions here. I think question number 14 is the very last question that we're going to do for this video guide and for this particular lesson. Lesson number 2 was indeed very long. Okay, so I know that AB is equal to BC. Okay, so here's AB, and that's equal to BC. Okay, so what that means is I have an isosceles triangle here. So I'm not sure if you see that. That right there is an isosceles triangle. Okay, and angle number 1 is going to be 40 degrees. So that's 40 degrees. And angle number 2 is going to be 45 degrees. And my goal is to find angle number 3, which is this angle right here. Okay, so that's our goal, to find that red angle. All right, so let's see what we can do with this particular problem. Okay, so I'm going to go ahead and start off with angle number 1 here, angle D, which is an inscribed angle. And let's go ahead and open its sides. So here are my sides, and it opens to this particular arc down here. And that's useful because if I take a look at angle C here, this inside angle, this is also an inscribed angle, and the inscribed angle, if I open its sides, it also opens to this exact same arc. So if the green inscribed angle is 40 degrees, that means this red angle also has a value of 40 degrees because the two inscribed angles open up to the same arc. So that's step number 1 on how I would approach this particular problem. After that, let me just erase all this. Okay, so that was going to be 40 degrees. Okay, after that, I would take a look at this inscribed angle, angle number 2, and if I look at its sides, and if I open those sides up, it opens to this particular arc right there. And that's going to be good because there's probably going to be another, this angle right here. If I look at this angle right there, angle B, part of angle B, if I open up those sides, that also opens up to the same arc. So this means this has to be 45 degrees. Okay, great. Let me erase this now. Okay, and after that, what I'm going to do next is, remember at the start of this problem, I did mention that this was an isosceles triangle. So if this is 40 degrees, that means this angle has to be 40 degrees as well. And that's because the two opposite angles are equal. Once we're done that, let's focus our attention on this smaller triangle right here. And we are given 2 out of the 3 angles. So one angle is 40, the other angle is 45. Then we can find this third angle right there. So that's going to be 180 degrees minus 40 minus 45. And if I do all that, 180 minus 40 minus 45, that's going to be 95 degrees. All right, so let me just erase this. And this is going to be 95 degrees right there. And now we can finish the problem. Let me just erase this, because we know that this entire angle here, angles on a line, those add up to 180 degrees, those two angles. So 180 minus 95, that would give us 85 degrees. So this is going to be, angle number 3 should be 85 degrees. Okay, so that now officially completes all the homework questions for the second lesson of the circle geometry homework chapter. Okay, thank you.